Hello everyone, this is my presentation and proposal to be the propulsion management of the 2021 LASC Cooperation program. First of all, I'd like to introduce myself. My name is Igor Novis. I'm a third-year mechanical engineering student at UFRJ, and I've been a member of Minerva Rockets for 2 years. The first year, I acted as a propulsion manager and developed the project I'm going to show you in the next slides. And now I work as the project management of the Aurora V2 sounding rocket. I also like to show the team that makes the project I'm gonna show possible. Of course, we have our propulsion engineers that design, manufacture, and test the project, and the instrumentation engineers that help with are responsible for the data collection to validate our results, and the operations team that is responsible for a safe and orderly operation. Now I'd like to show you an overview of the Helios solid rocket motor. That is the project I've been working in since I started in the Minerva Rockets team. It's an N-class rocket motor with about 12,300 Newton seconds of total impulse, a relatively large motor for competition rockets. It has a 55 bar of 5.5 MPa chamber pressure and a safety factor of 2.7. tested with experimental data. It utilizes KNSB propellant and potassium nitrate and sorbitol. It has a 7 segments per motor and with about 1,400 grams of propellant for each grain. In the pressure chamber assembly, we have our forward bulkhead. It's made with aluminum, and it has a pressure parts for measurement of internal pressure during static firings. It is very important to get this information to evaluate the performance of our rocket, of our motor. Of course, the bulkhead and the casing have thermal protection using EPDM, given that they are made of aluminum. In the aft end, we have our nozzle. It's a bell nozzle made with stainless steel, and the retaining ring, which is used to save weight, made of aluminum. Last year, we manufactured one motor and did a test campaign until the launch. And recently, we've just received 2 new motors to be validated and tested and flown in the near future. Last year, we had 1 successful hydrostatic test, 1 static test, and 1 partial successful flight test at LASC 2019. The rocket suffered a structural failure, but the motor operation was nominal as far as we know. This year, we have planned 2 hydrostatic tests, 2 static tests, and 1 flight test at LASC 2020. The hydrostatic and static tests are made at our installations at UFRJ. As shown in the figure, we have a mobile static test stand and pumps to do the hydrostatic test. This is a GIF of the Aurora sound rocket liftoff with nominal operation of the Helios rocket motor. And after showing all of that, after I have done all of that for the last 2 years, I think I'm qualified enough to be the propulsion manager of the 2021 LASC Cooperation program. Thank you for watching the presentation and have safe flights.